You're welcome to this channel, Mathematics for You tutorial. If it's your first time, thank you for watching and please subscribe to this channel. Thank you. Alright, the topic is applying the law of indices. Alright, applying the law of indices. Alright, you have grade 9 second period notes. This topic is from the curriculum. Alright, grade 9, specifically from the Ministry of Education, Liberia. Alright, so the first topic is applying the law of indices for 9th graders second marking period. Alright, so good. We are here. Alright, indices. Alright, we'll talk about indices. Alright, indices, they are like exponents, powers. Alright, so look at this one. So when we multiply a number by itself, the result is the square of that number. Okay, so indices, they are like exponents, like I said previously. They are like exponents. So for instance, we multiply 5 times 5 will be equal to 5 square, because it's what if you multiply a number by itself, right, the result is the square of that number. For example, you have 2 times 2 is equal to 2 raised to the power 2. Alright, so the product, if you multiply two numbers, identical numbers for that matter, alright, so it's equal to the square of that number. So we have the first law, which is the multiplication of powers. The first law we are going to look at, multiplication of power. This is the first law. Alright, so if you have a raised to the power m times a raised to the power n is equal to a raised to the power m plus n. Alright, let me explain this one. So whenever you are given a problem, if the bases are the same, so a there is known as a base and m there is what, an exponent or index. Alright, the singular form is what, indices is the plural form, and the singular form is what, index. Alright, so you have a raised to the power m times a raised to the power n. So whenever the bases are the same, alright, you take one of the bases and you add the exponent. If you are multiplying, if the bases are the same, you take one of these and you add the exponent. Alright, so it doesn't matter how many bases do you have, as long as they are the same, why, you take one of a and you add the exponent. That is for multiplication of power. Example here, okay, look at this example. You have 5 raised to the power a times 5 raised to the power e. Alright, it's the same. So what you do there, you take one of the base, then you add the exponents. Alright, let's look at the second law, which is what, division of power. So what division of power says? So okay, you have a raised to the power m divided by a raised to the power n is equal to what, a raised to the power n minus n. So whenever you're given a problem, if the bases are the same, alright, you subtract the exponent. As long as the bases are the same, you subtract what, the exponent. Okay, so look at the example. You have 3 raised to the power 6 divided by 3 raised to the power 4, which gives you 3 raised to the power 6 minus 4. As long as the bases are the same, you take 1, you subtract the exponent. Okay, so look at the third law, which is the power of power. Alright, so here you have parentheses open, a raised to the power m, a closest raised to the power n. So you have a raised to the power m, and it is raised to another power, which is n. Alright, so if you are given a problem like this, what you do, you multiply to both indices or exponents or power there, alright, which is m times n. Or another way is, you're going to it means that if you have a raised to the power m, alright, and also raised to the power n, so it means that you're going to multiply a raised to the power n times. Alright, you're going to multiply n times. Alright, so look at this one. So can we simplify an expression like parenthesis open 3 raised to the power 4, a closest raised to the power 5. Alright, you have 3, it is raised to the power 4 and also raised to the power 5. It's where the power 3 raised to the power 4 is raised to another power. Okay, so now you see the expression consists of 5 lots of 3 raised to the power 4 multiplied together. Alright, so this one, there are two ways to do it. Either you multiply the both indices there, or the indices there. Okay, alright, so it means that if you have 3 raised to the power 4, you can multiply 3 raised to the power 4 5 times, or you multiply the both indices there, you have 5 times 4. Okay, look at this one. Okay, so the first one here is what we are going to multiply the both indices there, right? The both indices there. So you have 4 times what, 5. Okay, you multiply the indices, then you have 4 times 5, which is give you 20. So you have 3 raised to the power 20. Or you multiply 3 raised to the power 4 5 times. Alright, if you can remember multiplication of power, alright, now you notice that the base is the same there, right? Good. Since the base are the same, what you do, you add the exponent. So if you add the exponent, that will give you 3 raised to the power 20, right? Yes. If you add the exponent, if you add 4 plus 4 plus 4 plus 4 plus 4, it will give you 20. So you're going to have 3 raised to the power 20. So let's look at it for the fourth law, which is power of products and quotient. This is the fourth law, power of product of quotient. So you have parenthesis open A times B, alright, it closes raised to the power n. So this one, that particular exponent or index, it is affecting to both variables in parentheses. So it is equal to A raised to the power n times B raised to the power n. Alright, that is for multiplication, or that is for our product of power or power of products. Okay, so look at the quotient rule. So provided that B is not equal to 0, you have parentheses open A over B, it closes raised to the power n. Alright, you have A over B. Likewise, this one, so the exponent is affecting to both the numerator and the denominator. Alright, that is why you have A raised to the power n over A raised to the power, or B raised to the power n rather. Okay, so another one there, if you notice that the bases are the same for division, you notice that the bases are the same, what you do, you take one of the base, subtract the exponent. Very simple. Very, very simple. If the bases are the same, you take one of the base, you subtract the exponent. Alright, so look at the example. You have 3x. Alright, you have the 3 there is what the coefficient, x is the variable. Alright, so that 5, it is raised to the power 5. So 5 is affecting 3 and x. Alright, 5 is affecting 3 and x. Alright, so if you simplify this one, you're going to get 3 raised to the power 5 times x raised to the power 5. Further simplify, you're going to get 243 x raised to the power 5. Alright, so therefore the quotient rule, you have 3 over x raised to the power 5. Likewise, this one, the same thing. So alright, so 3 there, the 5 is affecting both numerator and denominator. Okay, so let's look at the fifth rule, which is the zero index. Okay, the zero index is provided that A is not equal to 0. So any number raised to the power 0 is equal to 1. Any number raised to the power 0 is equal to 1. That is how you have A raised to the power 0 is equal to 1. So that A is a variable, it represents any number. Alright, A there is a variable, it stands for any number. Okay, look at this example. You have example 1, you have 22 raised to the power 0, it's just equal to 1. You have 1 million raised to the power 0 is equal to 1. Look at this example, example 2, you have 1000 raised to the power 0 times 2 raised to the power 0. Alright, so like I said previously, any number raised to the power 0 is equal to 1. So 1000 raised to the power 0 is equal to 1. 2 raised to the power 0 is equal to 1. Okay, so we have the sixth law, which is negative indices. Alright, so if you have negative indices, so you are going to write it like this. It will be equal to 1 over A raised to the power m. Alright, this is constant, it doesn't change. Alright, A raised to the power minus m is the inverse for A is 1 over A raised to the power m. Alright, look at this other one. It's provided that A is not equal to 0. For example, alright, for example, you have 3 raised to the power minus 2. So it's equal to 1 over 3 raised to the power 2. Alright, so if you have fraction, alright, fraction where the exponent is negative, alright, so what you do there is you reciprocate. What you do there is you reciprocate. You carry the denominator to the numerator, then you bring the numerator to the denominator. Simply means the number that is down you carry up, and the one up you bring it down, as you can see. Alright, so it is very simple, very easy. Okay, the seventh law, which is known as fractional indices. Alright, so you have A raised to the power 1 over m. Whenever you have a problem like this, if you have 5 raised to the power 1 over 2, Okay, so it is written as what from making to know that making to understand something. Okay, so you have 1 over 2, so that 1 over 2, is equal to our square root. All right, that symbol you see there, right, is equal to our square root. Okay, 1 over 2. But from 3, if you have 1 over 3, all right, 1 over 3 is what cube root, 1 over 4 is fourth root, 1 over 5 is what the fifth root, sixth root, etc. Okay, so if you have 1 over 2 is what square root. From 3 upward, or rather index can be what written there. All right, that 8 is a radicand, m there is what the index. All right, m there is the index, a there is what the radicand. Okay, if you do a topic that I will teach you, maybe in my next tutorial, which is sir. All right, so that m there is the index and a there is what the radicand. Okay, so provided that a is greater than or equal to 0, probably a could be 0 or greater than 0. Okay, from 1, 2, 3, 4, 5, etc. All right, for example, you have 4 raised to the power 1 over 2, like I said previously. All right, from 3 upward, the index it is indicated there. All right, so you have square root of 4 or 8 raised to the power 1 over 3, so you have cube root of 8, or 16 raised to the power 1 over 4 is equal to what the cube, the fourth root rather, the fourth root of what 16. All right, so there's another one. If you have a raised to the power n over m, so it is written like this, parenthesis open, you have m, all right, which is what the index. So it simply means that the denominator there, it stands as what the index of what a. All right, if you are writing the what solve form, okay, don't be confused. If you're writing it in a solve form, so that n there is stands as what the index, then a will be what the radicand, then the n, which is the numerator, will be the exponent, or why be raised to that particular power. All right, so for example, look at this one. You have 16 raised to the power of 3 over 4. Okay, so if you look at the rule there, so it's very simple there. So you have parenthesis open, the fourth root of 16, it closes, raised to the power 3. Okay, so if you simplify this one, the 4 root of 16 is equal to about 2. Alright, raised to the power 3. So if you simplify this one, you're going to get 8. So thank you for watching. See you in the next video. Thank you. God bless you.